Hello, everyone, and welcome to another build. We are going to make Rush Hour. You know, this kind of thing. Everyone knows this. I'm very excited to make this. I've been wanting to do this for a very long time. Ever since I started to learn game theory in programming, they showed us an example of someone making a rush hour in a backtracking algorithm to solve it. And I was just amazed by this, and I really wanted to do it. So my goal is to have something that you can build your own level, and you can play it by yourself, of course, and you can also let the computer solve it. It will show you exactly what it did, and you can go step by step, and you can see how it actually works. So I don't know how well I can make this, but I know it's gonna be a ton of fun. So yeah, let's just get straight into this. I'm going to do a couple of things. So one, let's name, not name, put the text up here. To rush hour. We will design the icon that goes over here later. Don't have to do that right now. Let's look at the back color. We don't want white. White is disgusting. Cornflower. It's not that bad. I think we'll go with cornflower. It's kind of soothing color. Alright, so what I need for it from the beginning, I just need to get the board in. Let's get that board in. Ink board. What did I do? Sorry. Goes new. And the board is 6x6, but we have also like a layer outside of it. Is kind of what I saw. So they're gonna go 7x7. So let's just do controls.add space and see how this looks. Yeah, it's too small, but it's looking quite nice, don't you think? I actually think I want the colors literally different. How is this the dark gray and this the regular gray? That should definitely be different. So let's just switch those, and we have to make this bigger. Okay, good. So we have our board. Now let's add in our trains. For now, we'll just do it, manually. Alright, let me just see if that works. So the thing is, there's like, what's happening here? We have two yellows colliding. You can think of it as like 4 and 2, but no, it's 3 and 3. So the ideal would be white to the right, red up, this yellow left, and then this yellow down, and then the white goes all the way through. Before we start, I actually want there to be a car class for each of these cars, so we can get to easy access to each of them. Alright, so what we want in this class, the length of it. So let's do length of the car, and then we want an int for the color. I think that's it. That'll have all my information basically. Public car. Yeah, put all that in. Now here I want to make a car array called cars. This is a car, this is a car, this is a car, and then this is a car. So we have 4 cars. So we have to assign cars equals to new car 4, because we have 4 cars. And now for every car, so car.0 equals new car. So his length is 2. His position, the 3, 1. And then it is horizontal, so we're gonna pass in true. And the color is white, so that's 2. You can see from this right here. I want to have an array that records all of the previous states of the board, so we don't accidentally do like reverse moves that bring it back to a state it's already been. There are some basic things that we can do to make this be a little bit more easier for the computer to do. If we can move our white to the right side, we should probably do that. Now the other thing is that we should move the horizontal cars, like this yellow one here in this picture, to the left to make more room for the stuff on the right to go out of the way. Now the last thing is the vertical cars. They can go up or down, but when it's when it's a vertical car that's 3, like in here, the 3 has to go down, because if it's up top, it's blocking the white. So that's the heuristics. We just finished that. The final thing is actually our solve rush hour util. Okay, so I just wanted to let you guys know exactly the logic that's happening here that I'm about to code, because I think it's quite interesting. So basically, we talked about how if we have a car that's 3, like this one over here, he will want to move him down. So he's going to look at those cars first. He will also look at the white car. I made it red so you guys can see it here, but he would look at that car if it can move right. Currently, he can't move right, so it's not going to focus on looking at this one. The algorithm goes through each of the cars and checks what it can do. So in this position, it will look at the purple, he will try to move him up, and then he will move him up again, all the way till this stage. And then he will start looking at the green. The green will go left, or it might go right, and then see, okay, wait, this doesn't lead to anything. All right, then let's try going left. And then it will start moving the yellow down all the way until the red has a free all the way exit. So basically, it just goes through all of the cars and goes through all of their possible movements, up, down, left, right, until he finds the one solution that actually works. So obviously, this algorithm isn't the best. It's very slow. It's very dumb. So at the end of the day, it gets the job done. You don't need any more than that. My guess, it's not gonna work. But if it does, that's pretty sick. Wait, did it? Oh, shit. Oh, look what I did. Look what I did. I put cars 0 equals this, cars 1 equals this, and then I did cars 0 here. And cars 0 again equals here. Like a... So stupidly. Anyways, I think that should solve the problem. Oh, another. Index was outside of the bounds of the array. Damn. Alright, I did that. Let's see if that fixes it. I just want to load in the... Oh, it's solved. Oh my. Wait, what? How did it move? How did that move there? Oh wait. Actually, wait. No, it's supposed to be there. How did it move to here? That's the question. Something's very off about this. Alright, so now we can actually see the board positions. Okay, so it looks like when I put in the board, it's just not right. You can see everything's 0. It should be -1. Over here, when I reset the board. Oh my god, I'm resetting it before example. I am so dumb. Let's see if that helps at all. Look at that. Sorry, it was way too big. There we go. That, I think, is the exact solution I was hoping to see. That it probably moved the white right, and then put that up, and then move that down, that, and then it moves out. Now what I want to see is if that's actually what it did. So how do I do this is simple. For every move it's going to do, I'm going to put into another array called moves or whatever. And it's going to store the information of the moves it does. I've added it. I think it will work. Alright, so you can see that it's quite a lot. So I'll have to find a way to, combine these together. Anyways, the logic is done. We basically made the logic, and it should also solve every single possible thing possible. In the next episodes, I will try to get this step thing that it shows me how it got to this solution much more cleaner. But yeah, thank you for watching, and stay tuned for the next episode.